everyone, my name is Timothy Lee Grant and welcome back to another video where we are going to be doing more journey through machine learning, trying to understand what's going on, how is it working, and improving our software engineering skills as we do it. So welcome, and yeah, let's get started. I will minimize myself right now. All right, so from I've done a whole bunch of videos. I think this is part 4, and in the previous parts we kind of went through how this is working. We're evoking something which is the Linnet model, which we have up here, not up there. We have in models. We have this Linnet, okay? And we are initializing it, and then here is kind of the forward layer of when we train our model. So this is how we train it. We just take the input parameters, which is a batch size. So there's 64 images at first, or each batch size. There's 64 images, and each image has a value associated with its grayscale. So how dark is it? And then there's 28 pixels by 28 pixels. So each image has those characteristics or those values associated with it. So we pass all 64 images in here, and then we just transform it, and then we output that. Okay, so we're doing transformations here in this forward. All right, cool. So that is evoked when we are here in our training, and we do this train right here. So here's where we actually do the forward pass of the machine learning model. So we're passing in the images for each of the batch sizes, okay? Then, now, today, I am going to be investigating what is this criterion. So, let's try to figure out what's happening here. And so it looks like I am passing in criterion here, here, here. Okay, so criterion is a object. All right. Neural network cross entropy loss. All right, so we already saw that NN is part of this torch. So it's the neural network functions that we're allowed to grab from with torch. Okay, so cross entropy loss, we can kind of go to that definition, and we see what do we see? Well, we see a whole bunch of stuff. What are we seeing here? Well, we're seeing a bunch of parameters. I see. Okay, so we're passing in parameters. Oh wait, no, this is optimization. So there's something else. There's an optimizer. What is that? I don't know what the optimizer does either, but cross entropy loss. Okay, so super init, weight, average size, reduce, reduction. Okay. So forward, return. So it returns what? Tensor. And we just do cross entropy. Okay. So now cross entropy is what? Go to definition, which is in functional.py. Okay. So I'm trying to make sure that I don't get too lost in the weeds. I feel like I know that this is going to be like a loss function, so I'm almost tempted to just say like, okay, it's a loss function and it's implemented somehow. I think that that's kind of what I'm going to do, because the the immediate thing that I'm trying to accomplish is I want to get this working and right now it's not really working. So let's just assume that, okay, cool, it's a loss function, and we're passing in the loss function. Now this optimizer, I know SGD will be stochastic gradient descent, so this is how we are adjusting our parameters. Okay, there we are. So we passed in those two parameters up to here, and we're getting a loss, which from the cross entropy loss, we're taking the outputs, which are given here. So this is our transformed data. All right. And then we are, where do labels come from? Okay, so labels are just, Okay, so I think probably what's happening here is we get the output, which is, oh, I see what's happening. Yo, do you guys see this? Remember, in the last video, this output, and let me close this, there's a lot going on here. Okay. In this output, back at this Lynette here, you see this output is a 10-dimensional list. So it's a list with 10 values in it. And that's what we're returning. So we're taking this FC3, we have FC3, we're passing in this transformed data, and it gets transformed into what? Into a list of 10 values. And we said that that was going to be the probability that each of the photo, what probability it is for each respective number, 0 through 9. So that's why there's 10 of them. Okay, so then what do is we take that output and we give the label of what it actually was, and then we can determine using, and which method of calculating a loss are we using? We're using that cross entropy loss. Okay, so we're passing in the output and the label, which is what it actually is. So then we can determine, like, what did our model say it was, and what was it actually? And then that's going to create some loss for each of our images. And I'm kind of curious, let me print. Okay, loss. Loss. Okay. So let's see what our loss function, actually no, loss dot shape, right? Loss shape. Okay, I'm curious what our loss shape is, and let me just run that, and we'll see. That will give us some useful information. Let's run it, see what's up. I'm not a huge fan of that. Okay, so torch size. Okay, that's not great. Why would this? So we have 64 images, and that's each batch, and 10 of those classes. That seems to make sense to me. All right. Okay, let's get rid of this. We don't need that. So the output shape makes sense to me. Criterion. Trying to figure out why the loss would be, like, I don't think that that should be nothing. So what I'm going to do is kind of go like this and ask GPT y. Here is my function. Here is the output. Okay. I am trying to understand why the size is empty. Am I doing something wrong? Okay. Let's see what it says. Your observations are accurate and nothing is wrong with your function. Let me explain why the loss shape appears empty. Okay. Your input images are batched with a shape 64, 1, 28, 28. Okay. And a size of 28 pixels. The model output, the model processes the input batch and outputs a tensor of shape 64 by 10. Yep, 64 images, 10 classifications each image. This means your model predicts 10 classes for each of the 64 images in the batch. Yep, okay. So why loss shape is empty? So torch size represents a scalar value with no dimensions. It's not a mistake and is expected because the criterion output labels computes the loss over the entire batch. Okay, so okay, and returns a single scalar value. Oh, so it's a single scalar? I thought it would be a loss for each image or something. I was expecting something completely different, which represents the average loss for the batch. Okay. When PyTorch returns torch.size, it's essentially a zero-dimensional tensor which holds a single value. If you want to see the actual loss value, you can simply print it like this. Loss.item. Okay, let's just do loss.item. Loss.item. And is that a function thing? Yeah. Okay. Okay, let's rerun this and see what we find. Ooh. Okay. All right. That's looking better, huh? Okay. Waiting for it to finish. All right, let's just keep coming here. This will give you a clear understanding of how your loss function. Okay, cool. So there we go. Look at that. Look at how beautiful it is. Okay, cool. So our loss is just a single number, and we say like loss is 0.056. So I think we want this number to be as low as possible. And this is computed for each batch of 64 images. Okay. I feel like these two lines are well, hold on. Let me also, before we get into these two lines, I feel like they are going to be kind of intense. Let's just look at this line, and then we'll look at the intense lines. So, running loss was initially 0 up here, and then we're continually adding to running loss. So for each batch size, we are adding the loss which our model created. So then we are doing that for each epoch. So in the graph, I closed it already. We were graphing epoch by epoch by epoch. And each time we do the epoch, we're hoping that our model's parameters are getting better such that when we run through our batches, everything is going to start to match and align, and the output is going to correspond to what we are saying in our labels. So our where is it? Our labels and our outputs start to match up, and therefore our loss value is going to go down. So we go through 65 or 64, what was it? 64 images over and over and over and over until we do all of our data set. And that's one epoch, and we're training the entire time, but we're also accumulating loss as we do each batch. Now, then what happens is we say, okay, cool, we ran through all of our data, we're going to do it again. So next epoch, we reinitialize loss to be 0, running loss to be 0, and then we keep adding and see like, okay, well now is our loss lower because our outputs are matching our labels. And if so, then we'll see that in our loss function. Here we go. Here is these two. And then we're just pending this to loss, a loss like list, right? Train losses is an empty list, yeah. So then we're going to be able to use that to graph things. So that's how we're calculating the loss. That's how we're keeping track of the loss. That's how we are graphing the loss. Okay, cool, because that also indicates that, or that also is something that I need to change. As we see, the loss function, it only has training data. It doesn't have testing data, so we need to kind of fix that. Okay, so anyways, let's start looking at this loss dot backwards. So loss so it's also part of, it's the same object, this criterion. So cross entropy loss has a backward method. No definition. Okay. So here's loss. I see forward. Do I see backward? Hmm. Out of 13. Let's these are all comments. So each of these loss functions has a backwards. Let me go back to the cross entropy. Okay. Let's just read the comment. So it doesn't look like it's defined here, but it's probably defined in whatever this weighted loss, which it inherits from. So we'll check that next. So, example of target with class indices. Loss equals this. Okay. So, output loss backwards. It's not making much sense to me, honestly. Let me just see if I can go to the definition here. L1 loss. Does this have? Go to definition. Okay. Loss. Okay, loss. Let's see. Model. Okay, model is like a base class. Now we are looking for backwards. Man, it would feel nice if we had like those whatever header files or anything that we could easily try to track down where things are going. Okay. Add module, get module, apply. Oh, did I see you? No. Are these in alphabetical order? So I need to go all the way up, but let me just control F again. Backward. There's a lot of back. It's okay. I mean, honestly, I'm not really seeing it right now. Backward hook, whatever that means. Anyways, I'm not sure what's going on with that. Okay, let's backward. Okay, let's just I am trying to understand what is happening with the loss.backward and optimizer.step. Okay. Okay, I'm just gonna put it like that and see if it understands where to look. Are crucial to processing the training of a neural network. Yeah, so I think that this is like where the heart of machine learning actually is within the backwards and the optimizer. So loss dot backwards. So what does this do? So we're doing the gradient calculation. So this line computes the gradient of the loss with respect to each parameter in the network. Okay? This line computes the gradient of the loss with respect to each parameter, meaning weight and bias in the network. Backpropagation. During this step, PyTorch calculates the gradient partial derivatives by propagating the error backwards through the network. The calculated gradients are stored in the grad attribute of each parameter tensor. Okay. So we can just do this loss dot backwards and that trains it, but PyTorch kind of abstracts the training away. And so as of right now, I don't quite know. I understand how backpropagation works. I understand how the gradient points in the direction of greatest ascent. Or sorry, the gradient points, yeah, in the direction of greatest ascent. So therefore that means we need the negative gradient, so we are minimizing the loss function. I understand that part. but what are our different parameters which we can use? How is it actually happening under the hood? I'm not entirely sure right now, but I think for me to accomplish my goals right now, I can just take it on faith that PyTorch is working, things are good, and it's abstracted away from me. Now, going forward in the future, that's definitely something that I want to look at, and we need to mess with the parameters, but not too worried about here. Step, I think, is just going to change my model or my weights and biases such that they improve the loss function. So they make the loss function smaller. And also, we have learning rate. Yeah, okay, so cool. We have the learning rate, and we also give the actual parameters. Now, what model.parameters? Where is that defined? Did I see? I didn't really see parameters. But, okay, I'm guessing that is inherited from this in module parameters. So this is how the learning rate is how big of a step we're taking. And then the parameters, I think those are the weights and biases of our LeNet model. Okay. And okay, so thinking about it a little bit more, the LeNet model, what is a model? That is the weights and biases of each of the nodes and all of those layers, right? Like this is the layers, the different layers that are there and how they're connected, and this is what forward is. So it's kind of, is this the architecture of how the neural network is created? Or connected, sorry, not created. And then these are kind of the structure, meaning each layer has how many nodes and how many inputs, outputs kind of thing. And so then the in module kind of just takes all of this and stores it in a state, which is, here are my model's parameters, and then based off of that, it will go to this optimizer step and just take a step and optimize each of the parameters based off of the back propagation that happened here. I think that's what's going on. Okay, so then we do here, so length is train loader, okay. That is each epoch. Length of train loader. Oh, what is it even printing? Train loaders, what? That's how many batches I believe we have. Then 5 epochs, so this is how many epochs we're currently on, and then we add the loss for that specific epoch, and then we print out our loss and everything for the epoch. So nice. Now let's do testing, because we need a test as well. So after we train, we also need to do testing. So let's first go and try to implement test. So module py, just close that. Oh, I also have test.py, right? Oh, okay. So how do I use this? Okay, so I have this file, and as I've said many times, I didn't write this file. This was generated for me by Copilot, so I need to try to figure out, like, okay, what's going on and how do I use it? Because I want ultimately to have that graph that showed my loss function decreasing. I also want to have the graph show for the loss of the test data. So I want training data and testing data. Okay. But when in my data set, didn't I get the train loader and test loader? So I think I have both, right? So I have test loader. So why in here does it grab the test? I don't necessarily think I need this. I'm going to actually comment all of this out. So, let's see. So, okay. For number of epochs in well, so this is definitely something which is good because I'm realizing that I'm coming into some problems. Like, how do I use this test.py? How do I use it from my train.py? Wait, hold on a second. That's not right. Because shouldn't I was thinking about here in my main to do something like this. Like test losses equals test and then model test loader like this. That's what I was thinking about doing. Okay, and then plotting that. But I think that this train.py should be kind of separate from itself, right? Like, I shouldn't be mixing test and train together because this is train.py, not test.py. I think I should be making a separate Python script, and that Python script should be calling train.py to perform training, then calling test.py to perform testing. So I think that's the way that it should be going. But okay, so how do I want to move forward with this? So okay, new file, and what should we call it? Let's call it maybe run.py. I don't know. Run.py, something like this. Okay, and then now let's do main def main here, and then I am actually going to, let's see, get rid of this or comment this out because it's not good. Now a lot of this okay, I think I know what I'm going to do. I am, let's see, going to get rid of the, okay, so this run.py, I am going to be creating a new folder. This train.py, I commented out all of the test.py, I already commented all of that out. So I need to try to figure out how all of this works, and this, it goes back to object-oriented programming. How do you actually evoke all of these classes? How do you get things to work together? I think that I'm going to do that in the next video. So I will be right back. I'm going to do this video. It's only 8 o'clock today, so I still have plenty of time to do more videos. So I am going to take a little bit of a break, and then we're going to get back. Today's video, or this video right here, was kind of orientating ourselves. Now we understand how the model is, or how the program is working in terms of how the things are kind of interplaying together. Now it's time to actually start modifying the code which was given to us by Copilot to actually make things work and to get it to be the way that we want it to be. So that will be the next video. Anyways, thank you guys so much for watching this video. My name is Timothy Lee Grant, and I hope that you guys enjoyed it. I hope that you, yeah, I hope you enjoyed it. Anyways, have a wonderful rest of the day, and I will see you guys in a few, I don't know how long my break is going to be, but anyways, I'll see you in a bit. Bye.